Okay, so now doing lesson 3.5, similar setup. How many moles are now in 57.2 grams of this stuff? We're going to mark this up the exact same way. Our known is this information here. That's our known. The thing that we're trying to find is the number of moles. We need to now look at our mole map. When we look at our mole map, we're going to start. We see that we are starting with a known of grams. Sorry, I've moved all my thingies to the back of this. We're starting with a known of grams. We're going to a unknown of moles. We're going to need that same conversion factor. So our setup, we're going to start with our known, 57.2 grams of lead carbonate, lead 4 carbonate. Our unknown is the number of moles. Just to make sure, and I wasn't really clear about how I did this in the last problem, but just to be very sure, you always want to make sure at the end that you compare what you actually found to what they asked for, because sometimes we will do a whole problem and actually answer the wrong question, which hurts so deeply when you guys are doing a quiz. So it just becomes kind of helpful to make that double check. So looking back at the last problem, we labeled our known. I'm just going to label our known again so that we know that that's what that is. Our next step is going to be to find our conversion factor, which again is going to be solved in the exact same way as before. So we need blank grams of X is equal to 1 mole of X. We know that that's the conversion factor we need because we are going from grams, mass, to moles. We're going to need conversion factor A in order to get there. Okay? Mass to moles, conversion factor A. That's where this is coming from. And just for the sake of clarity and color coordination, I'm going to go ahead and make that lovely conversion factor green for us. Where did I put that at the end? I think I put that at the end after we calculated it, so I'll hold off on that. And so we do the same thing again. There's 1 lead times that mass that's on the periodic table. You will always get a periodic table. Then you have 2 carbons times 12.01, which is that number on the periodic table. Then you're going to need 6 oxygens times 16.0. And again, the 6 is because 2 times 3. Then you're going to add all that up. You're going to get the same number we've gotten the last couple times, which is 327.22. Okay, so that's the number that we got. Now we need to put it in conversion factor form. Grams of PB parentheses CO3 close parentheses 2 is equal to 1 mole of PB parentheses CO3 close parentheses 2. And the number that goes there is this number. And just so you can remember that this is the conversion factor that we needed, I'm just going to go ahead and put that sticker right beside it. And then we're going to go into actually solving the problem, which is the setup. Again, we learned from our mistakes last time, but last time Miss Maddox did not give herself enough room. She keeps forgetting that she's a big and bubbly writer, writing in a composition book. So we want to give enough room this time. Your first box will always and forever and ever and ever till death do us part will be your known, So your known will always go in this section here. Okay, and then your second section, your next section, is always going to be your conversion factor that you needed, which in this case was A. Okay, so plug in 7.2 grams of PB, parentheses, CO3, close parentheses, 2. Only difference is figuring out what needs to go where. Now we have grams on the top, so we need grams at the bottom of this next step. So we're going to look at this section. The part with grams is the part in front of the equal sign. So that's the part that goes at the bottom of the next section. The other side goes up top. That's going to cancel. So we'll wind up with 57.2 times 1, which isn't going to matter. And at the bottom, we're going to need 327.22, which means that we are multiplying. Also notice that when I crossed things out, I crossed only the units out. I did not actually cross out the numbers at all. Okay, so I have 57.2 divided by 327.22. And I will wind up with, my calculator says, 0.174805941. First thing we're going to do is put that in scientific notation, which means the decimal needs to go after the first digit. And then we're just going to add all that other stuff back in. Times 10. We're going to look at how far we moved the decimal. We only moved the decimal from here to here. We moved it one place. Then we go back and look at this number. This number was less than 0, and so it is negative. And it looks like I'm at the very bottom of the page, so you may not be able to see that as clear. And then let's go ahead and make sure we write in our units, because without units we have no answer in chemistry. It's the difference between science and math. Math is all about numbers. Science is all about units. So from there, we're going to put this into significant figures. We'll talk more about that later, but to make a very long story short, going to the top, we had 3 digits here. Everything else pretty much had 3 digits or more, so our final answer will have 3 digits. So we're going to focus here, which means we need to look back here to decide to round. This is one of another cases where we're going to round, so we wind up with 1.75 times 10 to the negative 1 moles of PB CO3 2. And just to make things easy, I'm not sure I did this in the last problem. It looks like I didn't, but we want to make sure that we are consistent. We want to circle this final answer. And we're going to go back and we're going to circle this final answer. And just to make sure that it's clear to you why we even do this, chemistry, the language of chemistry is all in moles. So if I want to do a problem, if I want to solve something, if I want to make a solution, I have to know the number of moles in order to communicate that and to make those conversions. Without that information, I just can't. I can't make anything in engineering and biotech, medicines, all those things. Everything is converted to moles before it's actually converted to grams or even milligrams, which is what a lot of our medicines are in. All right, so there we go.